Absolutely. I love to talk about the Melvin. I'm so glad you asked. I've got a couple slides I can take you through that kind of explain what's unique about the Melvin. Would that make sense?
Of course.
All right, so first off, the Melvin, it's a heat engine. So it runs off a heat differential, hot end and cold end. There's no fuel that goes in there. There's no spark plugs, gas or oil or anything like that. It's just a piece of air that you're heating up and cooling down. It's fun. And this technology has been around for a long time. Well, what's unique about the engine is three things. And I've just got a little slide here that goes into it. First, the design, the physics of the design is unique. The second is the materials that are going into the engine. And third, the system configuration, the design of the system configuration is unique in how we allow different aspects of the system to be utilized for different functions. So let me just take you through those items. If I look at any heat engine, we talked about it's the differential from the cold to the hot. The key aspect is on the hot, the heat has to go in, and on the cold, the heat has to come out. And in our engine, it's going into air, so the heat from the outside going into the air, and then on the cold end, the heat coming out. That's the key. How fast can I do that, and how much can I push in there and take out? So in any kind of heat transfer, one of the key terms is the surface area that is exposed to the air that's being heated and cooled. So in the Melvin, we try to leverage that to get the maximum gain or the maximum amount of area involved in heating and cooling. In a typical heat engine, you'll have a displacer and a chamber, and usually they're cylinders. And I've got a little mock-up over here. If we look at this particular mock-up as a mini Stirling, let's say, and this is the hot side and this is the cold side, you can see inside it is this big can that's just pushing the air back and forth. Right? And this would be your typical configuration. Well, in the Melvin, what we did was we changed that geometry up, and we put a nipple on the end of the displacer, and we put a nipple on the end of the chamber. And what that does is, you see my little diagram here, that adds about a 30% gain in area for the surfaces that are heating and cooling the engine. So with that, we get a 30% gain in the heat transfer at both the hot and cold ends. The second thing we've added to the engine are these active heat transfer devices. I hate when that happens. And the active heat transfer device, once again, is aiming to maximize the area that is available for heating and cooling the air. And this would be an example of our heat transfer device. It's kind of like an immersion unit that you use for heating up your coffee or tea, right? As you can see, it just adds surface area that'll heat up and cool the air. And this is both in the hot end and the cool end. Once again, we're seeing about a 25% gain in area, so we see about a 25% gain in heat transfer. So from a design standpoint, the physics of how the engine is designed, those are some of the key elements that make the Melvin unique. Does that make any sense at all?
Mm-hmm.
All right, so next is the materials. And the materials I want to focus on here is one, the piston. The piston, we went from a cast aluminum piston, which was about 11 pounds, to a carbon fiber plastic piston, which is about 4 pounds fully done. We print that up on a 3D printer, which gives us some unique capabilities in how the internal structure of that piston actually comes to be. In addition, we're using aluminized steel, which gives us the heat characteristics of steel, but allows us to have the corrosion resistance of aluminum. And lastly, in our displacer, we're using a combined aluminum steel displacer, so we're getting a lot of strength, but not a lot of weight. The third thing that makes the Melvin unique is the system configuration design. And there are two specific elements within that I want to just highlight. One is the combined heat and power capability, where we have a water jacket on the cold end where you're taking the heat out of the engine, and that water jacket allows you to pull the heat out of the engine quicker, and it also provides you with a function to heat water. So now you have a combined heat and power system that you can utilize. And lastly, the integrated pressure system in the engine. It's a very simple hookup. Everything is enclosed in a housing, and it's a quick connect, pressure connector if you want to increase the operating baseline temperature of that pressure to increase the power output of the engine. So in a nutshell, those are the three elements that make the Melvin unique. Did that make any sense at all?
Oh yeah, it did.
Are you ready to get your Melvin?
Oh, definitely.